All right. So let's exit the compute node and go back to the login node. And let me just talk a little bit more about resource requests. I mentioned that the default amount of wall time that your interactive jobs run for are 60 minutes, or I think it was 30 minutes, I'm not sure. But you can specify how much wall time you need. Remember that for wall time, you need to separate it from the other resources using a comma and not a colon, and that's just because you specify the wall time itself using colons like that. So this one will give you one node with 16 CPU cores, 64 gigabytes of RAM, and you have those resources for 4 hours. Okay, as a matter of policy, your jobs can run for a maximum of 72 hours, okay, or 3 days. So if you envision that your job will take more than 72 hours, what we recommend is for you to checkpoint your program, which means that in some way write the results of your program at the end of or close to the end of 72 hours so that they can be used as input for your next 72 hours. Okay, so we call that process checkpointing. If for some reason that's just not plausible and you just need the job to run continuously for more than 72 hours, you have to submit a resource request, and there's information about this on the user's guide. Let's see, request. Sorry. Allocation? Yeah. So if a regular user needs to run a job for longer than 72 hours, the user must submit an allocation request, and there's a form to do this on the user's guide. And again, we want you to think very carefully about whether you really need your job to run continuously for more than 72 hours, or you can break it up into these chunks that you can run 72 hours at a time. And we'll review a request and figure out if we can help you checkpoint your software, or if you really need something to run continuously for 72 hours. It's not that we don't want you to run your jobs, it's just that we want to see if you can do it otherwise. All right, so let's go to the next one. So far we've been, we haven't been running anything. The only thing we've done is we've logged into a compute node and executed one or analyzed one of Nelly's files. We want to do more than this though. We want to analyze several of them at a time. But before we do that, we need to learn how to use the Palmetto in a non-interactive way. Okay, so if your job is going to be running for 72 hours, you want to be able to just tell the scheduler, here's my job, here are the commands I want you to run. Just run them whenever the resources are available. I want to turn my computer off. And then once it's done, send me an email or something. Okay, so this is what you want to be able to tell the cluster to do. And the way to do that is to write something called a batch script. Okay, so let's go ahead and write our first batch script. I'm in my login node here. I'm in the login node, user 001. And I'm going to navigate to data hpc / North Pacific Gyre / 2012-73. And here I'm going to create a file called submit.sh. And I'm going to edit this file using nano, so nano submit.sh. All right. And let's go ahead and add a little to this. And the first line of this file is probably the most cryptic. It basically tells whoever is trying to run this what to run it with. Okay, it's a bash file, and you know this because it ends with .sh. So it needs to be run with the program bash, which is located in /bin/bash. Okay. All right. The next few lines are instructions to the scheduler. Okay, and the specific scheduler that we run in the Palmetto is called PBS. Okay, so this one will specify the name of our job. The following line will specify the resources that this job needs. And this very last one will, well, actually that's not this. cd/home/username/data/hpc/not all right. Sorry about this. So here I'm essentially repeating most of the stuff we've been entering into the shell, but I'm putting it in a script called submit.sh. Right, and I'll give you all a minute just to type all of this in.